Assalamualaikum warahmatullahi wabarakatuh. Pbl Engineering Mathematics Ii, Chapter 2, Application of First Order Differential Equation. Okay, group members. Our leader, Ilham Adam, Nik Ahmad Ifan, Muhammad Takif, Muhammad Afi Hakimi and Muhammad Hanif. Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Afi Hakimi bin Amir. Okay, introduction. Two forms of application where ordinary differential equation were applied, namely growth and decay of population and Newton's law of cooling will be discussed. Okay, according to growth population of bacteria and increase in the number of bacteria in a population and not in the size of individual cell. The rate of growth is proportional to the number of population, or we can use this equation. Okay, according to the Newton law of cooling, it is a model that describes mathematically that change the temperature of an object in a given environment. We can use this equation for find that.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nik Ahmad Irfan bin Muhammad Azmi. Today I will share with you guys about Pbl table. What is Pbl table? Pbl table is a postmortem for question. That's mean we know what we need to answer the question. Okay. First, population of growth. Okay, you can see in the slide. Okay. In a particular culture, the rate of increase of bacteria is proportional to the number of bacteria P present at time t hours after the experiment. Given that the number of bacteria at the beginning is 10 to the power of 6 and after 1 hour is 10 to the power of 9. Find A, the number of bacteria after 5 hours. Then B, the time taken for the number of bacteria to be 3 times the original. Okay, let's see in the table up there. First facts. The number of bacteria at the beginning is 10 to the power of 6 and after 1 hour is 10 to the power of 9. That is a facts. Okay, next, ideas. Ideas means the reason. The number of bacteria increases. Number 2, when the time longer, the bacteria count more. Okay, next, learning issues. Okay, here we can use this question to both A and B. Pt equal to Po E to the power Kt. Okay, last, resource need. We use module in the author that from chapter 2. Then we browse some from internet.
Hi, Assalamualaikum. My name is Muhammad Hanif. So today I want to present about Pbl table. So I will present about Newton law. The question is a cup of Ali cafes with a temperature of 95% is placed in a room with a constant temperature of 21 degrees Celsius. A. Assuming that Newton law of cooling applies, find the cooling equation of the body. B. After 1 minute, the temperature has cooled to 85 Celsius. If the coffee is best served at 21 Celsius, how long do you have to wait until the coffee tastes the best? Okay. So the fact, a cup of Ali cafes with a temperature of 95 Celsius is placed in a room with a constant temperature of 21 Celsius. So we go to the ideas. Ideas mean reason. First, the cup of cafe become cooler after a minute because they are thermal equilibrium concept. Second, heat from room temperature can cool the cafe. So we go to the learning issues. For question A, we can use this equation. T bracket T equal Ts plus bracket To plus Ts exponent the power of negative kt. So for question B, we can use this equation dd over dt equal kd. So we integrate dd over d equal integrate k dt, and we get 1d equal kt plus c. So let's action plan and sources need. First, we use module in outer, and second, we browsing internet.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Muhammad Hashim. I will explain about the problem statement and the solution of the question 5, which is in the population growth. As you can see, there is a question from the question 5, and we just need to get from the A and B question, which is A is the number of bacteria for after 5 hours, and we just need to get the time of taken for the number of bacteria to be 3 times the original. Okay, there is an important point in the text that the rate of increase of bacteria is proportional to the number of bacteria present at time hours and after the experiment, and given that the number of bacteria for the beginning is 10 power of 6, which is the initial number of bacteria, and after 1 hours there is 10 power of 9 for the number of bacteria. So to answer the question A, we just need to insert and enter the formula, which is Pt equal to P0 E power of Kt. Okay, that's all from the question A. For the question B, we just need to how to find how long time taken to the number of bacteria after which is a number of bacteria is 3 times the originals. Okay, so as usual, we need to collect the data where we know the initial number of bacteria is 10 power of 6. The number of bacteria that we need, like 10 power of 9, which is after 1 hours, and we get a k after we get from the question A, and that's it. And just insert and using the formula Pt equal to P0 EKT to find the T. Okay, from the solution A, there is the solution from the question A. For the number of A, we just need to find, first we need to find a K. First of all, for the question to find the number of bacteria after 5 hours, to find a K, we need to use the number of the bacteria for 1 hours, which is we get it, and we know that P0 is the initial number, which is 0, which is 1, and you can see after we insert from the formula, which is a Pt equal to P0 E power of Kt, we get a K from this formula, and after we get the K, we just need to insert to the P5, because we need to find the number of bacteria after 5 hours. We K, and there is it. We get 1.0 divide 9 power of 21, which is the number of bacteria after 5 hours, and then for the question B, we just need to taken how long time taken to the number of bacteria when 3 times for the original of the number of bacteria. That's all. We just need to insert the formula, which is a Pt, which is we know that 3P0 is the 3 times from initial number, and we just need to insert to the formula, and that's it. We get through the loan equation, and that's it. We get a T, which is a time for the number of bacteria after for the 3 times.
Assalamualaikum and hi, my name is Ilhawadam. Okay, today I will talk about the problem and solution in the Newton law of cooling for question number 2. Okay, the question is, a cup of Ali Cafe with a temperature of 95 Celsius is placed in a room with a constant temperature of 21 Celsius. And the number A, we have to, assuming that Newton law of cooling apply, find the cooling equation of the body. And the B is, after 1 minute, the temperature has cooled to 85 Celsius. If the coffee is best served at 51 Celsius, how long do you have to wait until the coffee tastes the best? So the problem is, we can see in the slide, there is important point in that test, and 21 Celsius is mean the surrounding temperature, well, we can call is Ts, and well, in 95 Celsius is the temperature of the object, so we can call is T object, TO. So to answer this question, just easy. Just we have to just insert the formula. This formula is TT equal TS plus TO plus TS in bracket exponent power of negative KT. So when we solve this, so this is a solution. When we solve it, we can get the equation that's the question, not the question. To know is T equal 21 plus 74 exponent negative KT. So the B is, after 1 minute. 1 minute we can call the T has cooled to 85. So that means the coffee and the serve at 51. So the problem is, this question we have this is 51 Celsius. So when time is 1 minute is T1. So the D is 64 when 85 minus 21. So we can get this 64. So the problem is we still don't know the value of K. So to this day we have to find it when the T0. So this is step A. When the T0, when time to 0 is S is 95 and D is 95 minus 35. We can get this the equation, that ln D per 74 equation KT. So just want to, so after that we have to find the K, and to find the K just insert the T 1 and D is 64, so we can get the K equal to negative 0.1452. But this question, we have to find how long we have to wait to know the coffee test times when the 51 Celsius. So when the 51 Celsius, just insert the this T equals 51 and D is 51 minus 31. So just insert the equation in ln D per 74 equals to negative 0.1452 T. So we can get T 6.22.
Conclusion: help students to develop knowledge in a social environment. Provide students the opportunity to study real-world situations in order to learn new information. Increase student involvement and the availability of additional possibilities for the cultivation of talents such as critical thinking, problem solving, and autonomous working.